Hey there, Tens. I'm going to try to be fast, but I realized I wanted to make a quick video talking about this rule that I was talking about last time. That when considering a function that is a combination of functions, it will follow the rules for the highest power on x. So that is true, but I realized it's more nuanced than that, and we should discuss it a little bit. So here's what I wanted to say, because what you guys are doing right now is great for the IGCSE. So what I'm talking about is more than you need to know for the IGCSE. But specifically first, I want to talk about like these two functions are super similar because they both have this linear in there. And that x to the 1 there is the highest power on x because this thing is equal to 3x plus 1x to the negative 1 power. So the highest power on x is 1, meaning this thing should have the same general shape as that function on the top. So let's look at what that looks like. Function on the top is 3x, which we know a lot about. Y-intercept is 0, slope is 3, so it's going like change in y is 3, change in x is 1, or change in y is 6, change in x is 2, whatever those changes are, they divide to make 3. So great, we have this linear, and then this thing should follow that pattern. But there's one thing that looks really strange about it. So let's look at it and discuss it. This does not look like it follows the same pattern. Because I see that they're kind of the same out here and kind of the same out here, but in the middle here, this does crazy different things. So that's what I wanted to talk about is why does that happen? And it's because of something that keeps coming up that we need to discuss, but I keep leaving off, which is domain. Domain is all the possible x values. So the key here is that in this top one up here, in this 3x thing, come on, how do I do this? This top 3x has no problem with x. Like I can put in any number there and do 3 times that number and it's fine. So the domain here is all real numbers, which is to say all the numbers from negative infinity to infinity in the red line here, I can plug in any of those numbers and have no troubles. But the domain for that second function is different, and this is what drives the differences. The domain here is, I shouldn't use equals for this. I'll say is, well, I'll just say is. X is not equal to 0. So this is how computer programmers write not equal, and it's just the easiest way to type it. So x is not equal to 0. Why is that? Well, if I take that function, and I mean this function here, and I plug in 0, I get y equals 3 times 0, no troubles yet, plus 1 over 0. Well, this is like 3 plus something that does not exist, because this piece does not exist. So it hits issues. That's why when x is 0, like at that x equals 0, we have this vertical asymptote going on here. It's because x cannot be equal to 0. So what happens on both sides of it? Well, with a table, we could really tell. So let me just make a quick table for this. A table in that case, and I mean x and y, where this is the y value. So if I put in, -1, I'm going to get -4. And if I put in +1, I'm going to get +4. So those values don't help. What I'm going to use instead is 1/10 and -1/10. At 1/10, I would have 3 times 1/10 plus 1 over 1/10, which is the same as 3/10, or 0.3, 3/10 plus 10, because 1 over 1/10 is 1 divided by 1/10. 1/10 goes into 1 10 times. So that is 10.3, and I see at the x value 0.1 right here, I'm going to up here at like 10 and 1/10, wherever that value is. And if I go -1/10, I'll hit the same thing, 3 times, I'll just edit, well, no, I won't. 3 times -1/10 plus 1 over -1/10. I hit the same type of things, but this is -3/10 minus 10. So because of that, at -1/10 here, we're down at -10. Here's what that shows us, is that this thing, like these functions will be the same when we're far away from that asymptote, from where x equals 0. But when we get close to that asymptote, I can see on the negative side, this thing goes down towards the negatives. And on the positive side, when I'm looking here, I can see on the positive side, it went up. So that means it's close here, but then when we get near that asymptote, it curves away and does this thing. So just saying that when we hit domain issues, those domain issues will always look like a vertical asymptote like this, and we hit things that just look strange. So let me clear this off and just say, the domain for the first one is all real numbers, so we get this red line. The domain for the next one is x is not equal to 0. So when we're far from 0, these functions are the same essentially, but when we get close to 0, that asymptote happens. The same thing will happen in the next two. So if I look here, this function just takes x values and square it. Well, the domain is all real numbers, because I can take any number and square it. I have no troubles there. But in this next one, we have that 1 over x again. So the domain here is x is not equal to 0. So we're going to hit same type of thing. I'm going to take these two functions away. X squared, we know what it looks like. There we have x squared, which is great. When I do y equals x squared plus 1 over x, then we'll see far from 0, they should be the same, but near 0, weird things happen. So, and we see that, good. Far from 0, these are almost exactly the same out here. When we get close to 0, weird stuff happens. And if I wanted to know why did it go up on this side and down on this side, I would just do a table with like 0.1 and negative 0.1, and it would show me at 0.1 we have a large x value, and at negative 0.1 we have a large negative x value, showing that it's going down towards negative infinity and up towards positive infinity. These things are complicated, and this is more than you need to know. But I just want to recognize the fact that these asymptotes are happening is confusing to people, and I totally understand it. It's because we can't divide by 0. So that's what produces the weirdness. So this next function, here's what I want to say is, and this one should look really similar because these are all the highest power on x is x squared. It should have that same green graph x squared shape, except in this last one, we have a different domain. We can't divide by 0, so the domain here is x is not equal to 5. Because if I plugged in 5, I get 5 minus 5, and that makes 1 over 0. So we hit problems at 5. Well, okay, it's going to look strange at first. We see good, it does follow that x squared shape. And then at x equals 5, this is really weird. When we go and blow this up, you can see what actually happens, which makes sense, is that when x is near 5, we have that weird stuff happening. When x is far away from 5, it almost perfectly follows that green x squared shape. So just know that when you have domain issues like that, domain issues will come up as asymptotes like this. And just know that when you get near the asymptote, weird things will happen. But when you get far away from the asymptote, then the thing that matters is the largest power on x, unless we get close to that asymptote, and then we get the weird stuff happening. So here at x equals 5, we have that asymptote going on, and it's approaching it on both ends. And if I wanted to know in this case, like without graphing or anything, if I wanted to know what happens at x equals 5, I would plug in like a 4.9, and I would plug in 5.1. And what you would see is at 4.9, we get a large negative value. So I'll just say like negative and large. And at 5.1 would be on the right side of that asymptote, and you can see up here it's going large, so it's going to be positive and large. And I know I'm not actually plugging those values in. You could plug them into this function and you'd recognize that that's what's happening. I hope that helps to explain some of the weirdness with these. Thanks a lot. Best of luck.